Okay guys, now we have come to the next part of metric, which is 2.5 types of solution to system of linear equations. After this part, we are going to use all of the things that we have learned before, ERO, inverse and everything, to solve for linear equations. Alright, but before we go in depth about that, let us first identify what kind of solution that is actually available in the system of linear equations. Right, when I said the linear equations, the systems of linear equations, it means this, the ones that you always encounter before when solving for simultaneous equation, right? So there's actually three kind of solutions that is available, that is possible to be encountered later. The first one will be a system with unique solution. This is usually the case, right? Exam wise, this is usually the case, right? So let's say we have two variables here, x1 and x2, with two equations. We can solve for x1 and x2. So for this case, x1 is equal to -10 and x2 is equal to 4. This kind of system is known as a system with unique solution. One variable has solely one solution, right? And next we have system with infinitely many solutions, right? For example, this, right? For the other two systems, usually that is not usually the case, because the system can't really be developed in the first hand. For example, we don't really write down 0x1 plus 0x2 plus 0 equal to 0. So if there's any, and this will be a system with infinitely many solutions. Because why? Because we can't really solve for the x, right? So the most that we can do with this kind of equation is we'll just put, let's say, 2x2 to the right hand side, and the most answer that we can give is x1 equal to 4 minus 2x2, right? Like this. This would be the most, optimum kind of answer that we can give with this kind of system. So it means that it literally means that any value of x2 that you substitute that can be the result of x1, right? So it can be any number. It can be infinitely many solutions for this one. So this is system with infinitely many solutions. And lastly, system with no solution. It just means that you cannot really solve this, right? Just look at this one. It is impossible, right? With 0 input, but you still have 2 as the output. So basically this is no solution. Actually, it is nonsense based on this book, right? So that is the three kind of system that you can find in our linear equations. And right, previously this system always been solved by using simultaneous equation. Okay, you always solve the x and x1 and x2. Maybe you have x1, x2, x3 by using simultaneous equation. But for this chapter, we are going to solve it by using metric. Okay, so the first way to solve it is by using inverse, right? The one that we have learned before. Okay, the formula of inverse to find the x, to try to find the value of x, is A inverse times with B, right? So this is the idea. How can they come out with this equation? Okay, so first of all, this is the general form of system of linear equation. You have the first equation, the second equation, and so on. You have a times x at the left hand side equal to the equal to b, right? This is denoted as b, this is denoted as a and x. Okay, so if you look at our previous example, this is the a and x, where you have x1, x2, and you have 2, 0, and so on, and this is actually the b, 4 and 0. Okay, so first we just to prove how can we come up with this formula. Okay, so first we can change it in a form of metric, where this is what actually happened. We put all of the element of a here as one metric. Okay, and we will put all of the x that being tested here on next to it, multiply, right? Just like a multiplied with x equal to the b, right? So this is how it should be arranged. Okay, this is it. Okay, it is actually ax equal to b, right? In the form of metric, it is ax equal to b. So let's say that we try to multiply it with the inverse of a. What will happen is, okay, a inverse times with a. Based on our previous video, we know that a inverse time the a itself will give us its identity metric. Okay, so that is how we prove that it is the inverse, right? If you can multiply the inverse with the a and you get identity, that means that that metric is the inverse of a, right? So this is it. If a inverse times a will give you metric, which is also 1, right? So we can say that for this side, for the left hand side, if we want to make it simpler, we can say that, okay, so this is a inverse times a, so we just put it together. This is equal to identity, which is I, hence it is ix. Ix here is also means 1x, right? So 1 times x is x. So let's go back to our first this multiplication of inverse. All of this end up become x, right? And that leaves us with this side. So basically it is x equal to inverse times b. So to find the x, you need to multiply b with the inverse of a. In other words, if you try to look at in terms of this, okay, let's try to maybe, okay, if we arrange it like this, to find what is the value of x here, what we need to do is we just simply multiply b with the inverse of a. So basically we are going to find the a inverse first, then multiply with b to find the value of x. That is how we solve the system of equation by using inverse. Right? So let's see. Okay, this already been solved. Let's try to do this one. Okay, let me set up the system first. Alright, for this system of a linear equation in terms of metric, this is the form. We have a, okay, which is 1, 1, 1, right? 2, this is negative 1, 1, right? And 3, and then we don't have 2x2 here, so it is 0 and negative 1. So that is how you input a. Next we have x1 until x3, right? This is where is it. And lastly b, which is 6, 3, 0. So we have put it in this form. So to solve it using inverse, we know that to find the value of x, we need to multiply this with the inverse of this, right? So let us first find the inverse of a. Alright, as you may know, to get the inverse for this, we have two ways, or actually three ways. Okay, If for the higher order, we can use cofactor methods, and also that we have learned just now, which is ERO. So you can choose whichever one that you want to use if you have not instructed to. As for me, I want to try to use this ERO. Okay, so as usual, let's see whether it is invertible or not, just in case. Okay, so there you have it. We have actually a value for inverse, for determinant, so this is inversible. Okay, so let's proceed with to find the inverse. So this is already 1 done. We want to change this into 0 and 0, so we are going to do R2 minus 2R1. Okay, there you have it. Now let's change this into 0, which is also the same kind of process, which is R3 minus 3R1. Alright, so there we have it. Next, let's try to change this into 1. So how to change this into 1? So negative 3 times with negative 1 over 3, which will give us 1. Alright, so what we did is negative 1 over 3 times with R2. Right, negative 1 over 3 times with R2, which will give us this. Right, we already get 1 here. So next, let's change this into 0. So R1 minus R2. Okay, next we're going to change this into 0. So how to do that? Negative 3 plus 3 R2. So we have solved 2 columns. Now let's go to the third one. We're going to change this into 1. How to change negative 3 into 1? Just like what we did before, we are going to multiply it to negative 1 over 3. Okay? Alright. So for this one, negative 1 over 3 times 3 are 3. So next, let's change this into 0. So how to make 2 over 3 become 0? So basically just subtract with itself. So 2 over 3 minus 2 over 3. So where do you get that another 2 over 3? So times this with 2 over 3. Alright, there you have it. Just one more to go. Alright, 1 over 3. Let's make it 0 by, right, we are going to subtract it with, of course, another 1 over 3. So we're going to make this 1 over 3 times R1. So R3. So R2 minus 1 over 3 R3. Alright, so that is it, which is the inverse of this metric. So this is still not the end, because finding inverse is just the first part of solving a system, right? So we now need to substitute, right? We need to substitute this into the formula of x equal to A inverse times B. Okay, so now x equal to A inverse times B here, right? We know that it is actually 3 times 3, right? It is 3 times 3, right, with 3 times 1. So by right, later we should get, first we know that it can be multiplied, and then later at the end we should get 3 times 1, which later will give us the answer of x1, x2, x3. So let us calculate it. Okay, so we're going to multiply all of them together. There you have it, the answer of x1, x2, x3. Okay, let's try to tally it back with our answer here. It's not the same. Okay, so this might be due to, this is one of the, how can I say this, the weakness of ERO, right? Because it involves this kind of steps. You need to be careful. Okay, please check it again later with maybe cofactor method to see whether it is correct or wrong. Right? So I hope you understand it. Thank you.